in public services. This morning we have the agenda is I'm working for Fundingbox, which is one of the partners in this token project. And this morning I will give an overview of the token ecosystem, and my colleague Jorge Fernandez will give a talk about the token platform itself. Then we have Jesus Ruiz from the FIWARE Foundation, who will talk about public commissioned blockchain networks. And then we have Stefan, who will talk about notarization interaction with the NGSI LD, which is an introduction to the Canis Major component. Okay, so to kick off, I will share my screen. Please let me know, somebody, if you can see my screen.
Yes, we can.
Okay, thank you. So to give you an overview, what is Token? Token is a Horizon 2020 project that kicked off at the beginning of 2020, and it'll run until the end of this year. So as part of the Token project, we have developed an ecosystem to enable an experimental ecosystem that simplifies the implementation and adoption of blockchain and decentralized technologies within public services. So we've done that via two things. One, we have developed the core technology, which we call the token platform. And this offers a plug and play services and components to allow the implementation of DLT and blockchain within an application or a solution. And on top of that, we've also developed 4 use cases to show the simplicity of working with this token platform, and also the benefits of adopting blockchain and decentralized technologies within public services. So the token platform, it's based on 4 different blocks of services. We have blockchain notarization, which includes stamp and anchoring components, and also the Canis Major, which one of my colleagues will talk about later. We have decentralized identity, decentralized storage, and messaging and events streaming. So all of these different components are available either via an API on the token platform itself, or they're separate components that are accessed outside the platform, but it's all under the umbrella of the technology that we've developed as part of the token project. And how do all of these pieces come together? So we have, like I say, in the core of the project is the token platform, which is the core technology. And we've developed 4 use cases to make use of this token platform, or to showcase the usability of the token platform. The 4 use cases that we have public accounts management, which is a use case based in the city municipality of Capillarity in Greece. This use case is to do with improving the procurement processes, and there's also an e-voting component that they have developed there. In Belgium, we have a use case in the city of Wiedemann, which is improving the last mile logistics and the local economy there. In the city of Santander, we have the data valorization services. So this is looking at all of the data that is collected in the city via IoT devices and making use of that data in a transparent way. And we have the public funding distribution use case, which is developed by Fundingbox, which is the company that I represent. So I'll briefly give you a little overview of each of these use cases, what has been developed, and how they're making use of the token platform and services. So the first one is the public funding distribution use case. What we're trying to do with this use case is to make the funding process similar for both parties, both the applicant and the granting body, with the idea of making the whole process more efficient, cost-effective, transparent, and in the end, creating product savings. So the idea is that for the granting body, we want to simplify the process, save time on running an open call to distribute these funds, improve the trust and transparency between the funding body and also the applicant, save time on due diligence. So there's SMEs and funding bodies spent a lot of time checking legal documents and making sure that, for example, an SME is an SME. The idea is that this application, through the use of self-sovereign identity and verified credentials, will reduce the time taken to do this step. And to make it easier to find the right startups and SMEs. So this is some of the feedback we got during the research for this particular use case, is that it's difficult for the SMEs to find the right funding and vice versa. So this particular application use case that we've developed helps with that problem. On the other hand, for the applicant, the idea is that this application will make the whole process of applying for public funding easier. So simplified process, data can be reused for many opportunities. The idea is that they create their profile and then they can reuse that data to apply to different opportunities. They can save and verify credentials and reuse these documents and certificates when applying to other opportunities. It improves trust and transparency, and easier to find funding opportunities. So when they create their profile, it will make it easier for them to find the right and be matched with the correct funding opportunity and training. So I've just created it because we don't have much time. I've created just some screenshots of the application here, some screenshots of each one. So this is the applicant dashboard. So here you can see the applications that an applicant has applied to. They can access any training that's relevant for them. They can track their progress and go ahead and update their fundraising profile. So a fundraising profile is something like this, where they can enter all of the information about their company. So anything to do like a typical business pitch, their business plan, previous funding rounds that they have been successful in. They can enter information about their team, metrics and KPIs, so what the company has achieved. And they fill in this information once, and that information can be used then in the future to apply to different opportunities. Once they've completed their funding profile, they then have access to funding opportunities that are suitable to them. So they will get notifications about opportunities that appear that suit the profile that they have created. And then they can go ahead and apply to one of those opportunities. So when they apply to an opportunity, they sign it and submit it, and this creates a submission credential. So this information is timestamped and stored on the blockchain. So later on, we can check that this information was not changed or modified, and they can also view the data that was submitted as part of that application. On the other hand, we have a funding body dashboard. So a funding body can go into this application, create their profile, and then create a new opportunity. And as startups or applicants apply to their opportunity, they can control all of it and view everything within the applicant's dashboard. So they can also manage the process in here, where they can accept, or if an SME or an applicant is ineligible, they can change the status within this Kanban. So that's a very quick overview of the funding body use case. The other use case that I mentioned was this one in the municipality of Capillarity in Greece, where they have created a use case to manage or improve the management of public accounts. So here, this is to do with the procurement process within the municipality of Capillarity. And what they have done is created a new application where the entire process is managed and tracked and auditable. So every player that's involved in this particular use case can sign in, and they can give their authorization, and the process moves to the next step. So all of the data, in the past, all of the data was fragmented. There was different technology being used, so it wasn't very efficient. So now with this process, everything is managed in one place and it's auditable. So all of the steps are tracked and time-stamped and hashtagged and stored in the blockchain. So it makes the whole thing more transparent and secure. On top of that, they've also developed an e-voting system within the city, which allows citizens within the city to vote on certain topics, and this involves the citizen within decisions that are made within the municipality. and this is using SSI, self-sovereign identity. So it's secure and anonymous for the citizen who's voting. And there's also an audit trail, secure communication. So it creates kind of a transparency and confidence within the city. And this is just the status of where this particular use case is. So they have already launched the first version of the procurements and the e-voting system. And next steps is just modifying or I suppose integrating and iterating on this particular application. The second or the third use case we have is called the urban logistics use case. So this is a use case that was developed within the city of Leuven in Belgium. And there, the particular problem that they were trying to address is how to promote local goods, how to enable zero emissive transport, how to optimize city access for motorized vehicles, and create trust in the collaboration within city logistics, and also to make it profitable and efficient for all parties. So in the city of Leuven, they have certain static times when logistics trucks can enter the city and do their deliveries. So this is a static window at the moment, and so it's quite a manual process that's managed through just lights, and there's no, it's not dynamic. So what they have done is created a system called the dynamic access control. So what they've done is developed a system based on a number of requirements that are set by the city on when a logistics truck can enter the city or not. And this is based on a number of criteria, like if they're carrying local goods, if they have consolidated with maybe another logistics provider. And the idea is that they reduce the traffic and the congestion within the city and make it more dynamic, so you don't have just set times when trucks can enter the city. They can do that based on these certain criteria. And that's what this dynamic access controller does. So they have built this using the token platform technology in the background. It gathers the orders, it requests access to the city, and then this dynamic access controller verifies the requests and grants access. So there's a communication between this dynamic access controller and the city. And that's the dynamic access controller. So that was launched in April, and there was a test case done in the city of Leuven on that. So that has been completed. And the last use case we have is to do with data valorization in the city of Santander. And the idea here is to collect all of the IoT data. So there's in Santander, there's an IoT data marketplace that's supported by the municipality. So it offers real-time and historical data generated by IoT deployments points around the city. The idea of this use case was to introduce distributed ledger technology into the IoT marketplace in order to create a business opportunity, or to evaluate, valorize this data that's being collected, and also to create a sense of security and transparency around this data, so users can know how their data is being used. They can, the data can be monitored. It ensures the quality and integrity of the information. And in the future, they want to commercialize this data, so data consumers can pay to use this data, and that will be managed through the use of smart contracts. So there's a number of benefits to this data valorization use case. For example, it's exploiting the data generated and also creating new business opportunities for the city of Santander. For data consumers, there's a quality, it ensures the quality of the data being collected. There's an increment of data offer, and it can develop new services without the IoT infrastructure deployment. For the municipality, it's a self-sustained marketplace. It enables new services for city and citizens, and the idea is that it will create new business opportunities for the municipality in the future. So that's a whistle-stop tour of the use cases that we've developed. If you want to see or learn any more information about these particular use cases, you can go to the Token Platform website, or you can go to the token website, sorry, and there's a link in there where you can click on request more information or even request a demo. So if you request a demo there, any one of those use cases, we can set up a demo and show you how it works. And the idea is that you can learn how to either replicate these use cases in your own city, or maybe even develop your own use case, and we can help you with that. So now I will hand over to my colleague Jorge, who will give a little more information about the token platform and how that works.
Thank you, Lynda. So I will share the screen. So give me 1 second. Okay, so can you see the screen now?
Yeah, we can see it.
Okay. Okay, so I am Jorge Fernandez. I am CTO of Fundingbox, and within Token, I am responsible or one of the persons responsible for developing the Token platform. So today I will do a very brief introduction to the Token platform and what it offers. So basically, the Token platform offers or aims to provide a set of plug-and-play services and software components to start experimenting with decentralized technologies. As the benefits of using the platform, we can say that it's an easy way to start experimenting with decentralized technologies, since you don't need to deploy your own infrastructure, which is usually sometimes difficult when we are talking about blockchains or this type of networks. Additionally, it's composed of free-to-use services and open source components, and also regarding the blockchain-related services, it's also compatible with different types of blockchain networks, and we are working also to make those services compatible with EPSI. So as I mentioned, the platform offers some ready-to-use services. So basically, you just to start using the services, you just need to create an account, get your credentials, and start consuming the services. To access the services, all the REST APIs are accessible via an API gateway, which basically handles all the access and authorization, except for the Canis Major component and the third solution, since they are not integrated into the API gateway. They have, in the case of CERT, they have its own API, and in the case of Canis Major, this is a component, a software component that you need to deploy on your own premises. So when we talk about the services we provide via the platform, basically we are trying to provide these highly scalable RESTful services components and across 4 major blocks that are basically blockchain storage or blockchain-based notarization, decentralized identity, decentralized storage, and finally messaging and events streaming. So regarding each block, when we refer to blockchain storage or notarization, we offer 3 different solutions: 2 REST services plus 1 software component. The REST services are the stamp API and the anchoring API. The stamp API is basically for provide these tamper-proof timestamps for any digital content as a proof of existence. And regarding the anchoring API, is basically the same but for metadata. So instead of storing only the hash of a transaction or whatever, you can also store on the blockchain any type of metadata. This could be useful, for example, if you are storing schemas or any non-personal metadata into the blockchain. Additionally, we also offer this Canis Major component, which is a blockchain adapter that supports the persistence and verification of transactions on different blockchains. In fact, Canis Major is compatible with more than 1 type of blockchain network. When we talk about decentralized identity, we have this third SSI solution, which is basically a full-feature SSI solution that offers a custodial wallet, but also the services for issuing, verifying, and revoking verified credentials. So, well, with this solution, you can have a full-feature thing to start implementing, not just as an end user, I mean, using the wallet, but also if you want to become a verified or an issuer of credentials, this is the solution for you. Regarding decentralized storage, we have these IPFS related services that comprise two types of services. Basically, the first one is the gateway, and the second one is the pinning service. The gateway offers access to retrieve any type of document stored into this network, but also the possibility to upload any type of binary data there. And regarding the pinning service, is a way to create a redundant storage and make sure that your documents or binary data will remain there for as long as you need. And finally, we have the token streams, which is basically for messaging and events streaming, but we are using it for creating secure communication channels between two parties. So basically, this creates a communication channel between two different parties and automatically encrypts and decrypts the data in transit between the two different parties. And well, this is all. Basically, this is a very brief introduction. If you want to know more, you can go to the token platform website. You will find more information there, also some documentation, and you will be able to create an account and register your application, or more than one application if needed, and generate the credentials to start consuming the services. So thank you, and that's all.
Thanks, Jorge. Now we'll pass over to Jesus, who will talk about public permission blockchain networks. Jesus, are you here?
Hello. Yes. Can you confirm that you can hear me very well? Or
yeah,
well, at least?
Yeah, I can hear you well. Yeah.
Okay. Okay. So then let me just share the screen. Okay. And then if you can confirm that, do you see my screen already?
Yeah, I see your screen.
Okay, so now very briefly, I'm going to talk about something called public permission blockchain networks. But I'm going to talk about the essential model that we need because in the blockchain space, most of the focus is on the top of the stack. Okay, and then why? Because we are used that for applications which are based on internet connectivity, this internet connectivity is a given. We assume this, so we don't even put a requirement on our applications to use internet connectivity or internet connections because it is already there. But when we are speaking about blockchain applications, we have something missing, the elephant missing, which is the blockchain network. Now, let me give you some historical hints on so we know what type of blockchain networks do we need. Well, surprisingly enough, Spain in 1972 was implemented the first public network in the world, communication network, not blockchain. Okay, it was way before the actual internet, but it was a network of communications. And you can see, I'm sorry that this is in Spanish, okay, but you can see the source here also of this document. But this was a public access or an open access infrastructure. So mostly businesses at that time could just pay for access and then connect to the network and connect nodes that were not just belonging to the same organization. If we look at the evolution, then you know from history, because that was in 1972, but today we have the internet infrastructure. Okay, I'm not talking about the content providers and the Google of this world and search engines. I'm talking about the cables, about the connectivity, the infrastructure which is needed for our applications to work and for our society to work. And then right now, this internet connectivity is a common good which is essential for society. And in advanced societies, we assume that this is a given. But this is not a given, for example, in several countries in Africa or whatever. And if there is something like wars and so on, you know that they attack these infrastructures. Why? Because they are essential for the society. And they have to comply with some properties. They have to be inclusive and open access with a reasonable price. Okay, there's nothing free if the resources are limited, but it has to be reasonable, and it has to be regulated. But the governance cannot be by a single entity. If you look at the internet and the internet cables, there are many private companies, but there are also many stakeholders. So this is a multi-stakeholder governance, which is collaborative and decentralized. Of course, anonymous entities are never in the internet. Specifically, juridical persons, for example, businesses, are never anonymous in the internet. Okay, they cannot. They have public identities, and they have to be responsible for anything they do. And whenever they engage in some relevant transactions, identity is a must. Okay, protection to the citizen and consumer. Okay, this has to be a focus, and especially vulnerable collectives, because we want an inclusive society. We don't want a network which is only for the rich. Okay, and it has to be sustainable and ecological. And these principles are also embedded in the Europe Digital Decade Compass. If you look at the picture, you see that, of course, in the digital world, we have to improve the skills of all citizens and participants. Okay, not just citizens, but businesses and so on. We have to make or improve the digitalization of businesses and also of the government. But there is something that people normally don't see, okay, because focus again is on the applications, because this is where the users are, where the businesses are, and so on. But the infrastructure is essential. Who cares about the infrastructure? Well, in this case, Europe. And we have to ensure, and this is in the digital compass, to ensure access to excellent connectivity for everyone, because Europe is very well connected, but not enough. We need much more, because we need to arrive to all the citizens. Okay, that's the internet. The internet is very advanced since 72, but when we speak about blockchain, we are just at the beginning. So again, Spain, 2018, the first public permission blockchain network in the world was created with a model which was very strange, a strange animal, because at that time you had something like Ethereum or Bitcoin or whatever, which is anonymous access, wild west. So the law of the strongest, the richest, the smartest, and so on. No consumer protection. If you make a mistake, then you don't have any way to recover the funds. And then you had some companies. Sorry, I get a message saying that somebody cannot hear me. Can you confirm that you still hear me?
Yeah, I can hear you.
Okay, because there was. Yeah. Okay. So I guess. Okay, and then at that time, in contrast to anonymous access or anonymous blockchains were permissionless, okay, where everybody could enter, but at the end we see what has happened: centralization, the law of the strongest, and so on. You had something called private consortiums, banks with banks, energy company with energy company, but they were restricted access with non-inclusive rules and mono application, financial, logistics, whatever, okay? And then we needed something different, something which is inclusive and open, collaborative, decentralized governance. The servers, the machines in the network require real identities, strong identities, focus on the protection of the citizen and the consumer, and sustainable and eco-friendly. That was a model created in Spain, but it was so strange that then the European Commission started to look at this, and then I personally went to the European Commission to explain this governance model, because that was very, very strange, because they wanted to create EFSI. And EFSI is a public permission blockchain network, okay, which is considered a common good. It's not the ownership of a given company or even a given business sector, for implementing cross-border services, both public and private. Initially, they are doing public services, but the objective in the future is to include both public and private services, improving the lives of the citizens. This is the point, not to make money, it's to improve the lives of the citizens with a decentralized governance where no entity dominates over other entities and no central network operator. There is not this blockchain as a service. This is not a blockchain as a service. There is not a hosting operator or operator of the network. The network is operated collaboratively and in a decentralized way by the member states. Okay, and then focus on the real economy versus the financial economy. So this is for the real lives of the citizens, to improve the efficiency and the trust in all services of the citizens, and away from financial products which are only for the few, the ones that have money and can invest and so on. Okay, but this FC network, and this is my vision, cannot just provide everything which is needed in a blockchain network. In the same way that the internet is not one network, but is a network of networks, then in the blockchain space, we're going to see a network of networks. It's a different technological implementation, but the concept should be exactly the same. And I have depicted here what I think that the FC is going to focus on, well, what FC is focused on, which is cross-border use cases agreed by all member states. So they all have to agree that the use case is important. But then you have, for example, several countries where they have more specific use cases affecting one or more countries. They want to maybe interoperate bilaterally or trilaterally, and they cannot just wait for the use case to be put in general in the FC network. So they are going to interoperate essentially by anchoring in the general FC network using the identity and the trust of the backbone network. And this is going to provide interoperability across national, regional networks, and also with private consortiums. Why not? If the private consortium follows the same rules and uses the same digital identity technology implementation as FC, then they can use these digital identities for any use case that they want in the real world, like it happened right now. So just to summarize, we need a blockchain network, okay, you see here, which is something different, and this is again the missing elephant in the room, which is a common good, which is not controlled by a single entity, which is created as a consequence of public and private collaboration. So this is not just public permission, it's just not only from the public administrations and not only from the private sector. We need public-private collaboration in order to create this blockchain network, which is open to everybody. Everybody can participate, but with digital identities, like with the internet, like with any public service which is limited. You need the digital identities, or sorry, you need the identities, which is as big as possible because of network effects, and which is general purpose. So once you are in the network, that's it. You enter into the internet, okay? You contract internet with your internet provider, and you contract blockchain access to your blockchain access provider. But the blockchain, like the internet, should not be operated by a single entity, just the access. Once you are there, you can deploy the use case that you want. Nobody can say, no, I don't want your use case, okay? And it is sustainable and ecological. And that's the blockchain network. And now let me talk a little bit about what we have been doing in the collaboration between Alastria, okay, and the Alastria Association and FIWARE. If you know something about the FIWARE infrastructure, you can recognize here the whole set of components. But the most important thing is and you will see a description later of the Canis Major component, which is exactly this thing, okay? This is just a very small but very important component which ties together everything that you do in the smart cities, smart environments, and smart data spaces with the blockchain. The first implementation, of course, is with a production blockchain, which is already working, like the one from Alastria, but this is independent. As soon as the blockchain implements some standard features, Canis Major can be used in order to connect any Power by FIWARE application with the blockchain in a very transparent and seamless way, okay? And that's the set of properties that Canis Major together with the FIWARE infrastructure provides to the applications. Timestamping, immutability, and censorability. Of course, in the future, not right now, we need identity binding, which is this thing that we need in order to make sure that all actors are responsible for their acts, and then privacy, okay? Because in the blockchain, privacy may be a concern, but this is just a set of best practices and implementation to achieve privacy. And this is my last slide.
Great, thanks, Jesus. Now we'll pass over to Stefan, who will give a short introduction to Canis Major. Stefan?
Okay. Yeah, let me share my screen first. Okay, hello. So my name is Stefan Wiedemann. I'm architect and technical lead at the FIWARE Foundation and also the main developer of Canis Major. So I will give you a short introduction into what Canis Major can do and how it works. Okay, first, what is Canis Major? Canis Major itself is an adapter that supports the persistence and verification of NGSI-LD entity transactions into blockchains. As Jesus already mentioned, we are currently support the persistence into blockchains like Alastria. The requirement that we have is that they are Ethereum compatible. So you're not forced to use Alastria. You can basically use anything that implements that interface. Canis Major itself handles the creation or can handle requests to entity creation, entity update, entity retrieval, and also batch creation, and therefore notarize those transactions. The API of Canis Major itself is a subset of the official NGSI-LD API. That means that you can use your normal NGSI requests, send them to Canis Major, and Canis Major can handle the whole work around notarizing the transaction itself and putting it on a blockchain. Canis Major deviates from the NGSI-LD API in the fact that it responds to those requests with the transaction receipt. This is done because the normal request will be handled by the context broker, and for someone directly calling Canis Major, the receipt of the transaction is in the end more interesting than getting the same response twice. In addition to the blockchain, all transactions are also stored as an entity inside the context broker. That helps to basically query for them and store additional information. In this case, especially the link to the original, original accessed entity. And in addition to the NGSI implementation API, Canis Major also implements a query API where you can retrieve all the transaction data that was stored by Canis Major based by the entities they are related to. So when I do store transactions in relation to entity A, I can query Canis Major to give me all transactions related to this entity A. We will see more of this later in the demo. Okay. What else? Canis Major uses a smart data model that is directly created for distributed ledger technologies. It will look very, let's say, familiar for most of the people that are using already some blockchain technology. So it has the hash, the block number, the address that signed the transaction, the gas used, and additional stuff. You can see the data model that we're using here in the GitHub for smart data models. Canis Major relies on this one. What we also do is that we only store the hash of the transaction of the entity and the change of it instead of the whole entity. This has two benefits. It's less costly because we don't have so much data to store in the blockchain. And we also don't have the plain text data available in the blockchain. As usual in a blockchain, the transactions can be seen by anyone. So the data would have been visible there. But in some cases, you don't want to have the data visible there, but only the ability to verify that the transaction on the data happened. So we do hash the entity and store only the hash inside the blockchain. The hash can be reproduced by simply rebuilding the same hash of the entity later, which means you have to alphabetically order all the properties of an entity and then build the hash set with the given functionality. So now, how does the actual architecture look like? In the end, Canis Major is kind of a microservice that can stand next to the context broker. In this case, a client application has to call both applications. One, the context broker that has the NGSI-LD API, and also is made sure to do the actual persistence of the transaction to the blockchain. When is made sure receives that request, it will hash the actual change and persist it to the blockchain. After made sure receives the receipt from the blockchain for this, it will also store the receipt in the context broker and creates the relation to the original entity that the client application created inside the context broker. This has one drawback because it in the end allows the client application to decide what transactions should be notarized in the blockchain. Therefore, we have a different deployment model where we put a transparent proxy in front of the context broker that handles every request going to the context broker and first forwarding the request to Major so that Major can handle the request, persist it on the blockchain, and the proxy will forward the request to the actual context broker after it is notarized on the blockchain. This will make the whole process a little slower, but it takes away any option to censor which transactions should be notarized so that every change in the context broker is also in the blockchain. One additional consideration if we do store transactions on the blockchain is that they have to be signed with some kind. We support two models here. One is that Major can sign the transactions itself with a key that has to be provided on startup of Major. We call it the default key. That means every transaction that is signed that way will be connected to Major. This has a drawback that we don't know who the client was that actually created the change on the context broker. Therefore, we support a second mode of providing the signing key, which is that the client signs information about the signing endpoint also to Major. We do this by a couple of headers that can be added to the actual request. And in this case, Major will read the header information and then create the transaction object and send it back for a signature to the key store of the client that was configured in the headers. When the key stores had signed the transaction and send it back to Major, Major can persist the transaction on the blockchain and then go for the normal way to the context broker. This has the benefit that the transaction itself on the blockchain can be associated directly to the client that was responsible for it, so that we can in the end see this transaction was done by Alice, this was done by Bob or whomever, and we can verify that they actually did that. Okay, we will see this closer in the demo scenario now. I created a very easy one where basically we have a customer, Alice, that orders a packet in the store. Then we have a courier, Bob, that takes the packet for delivery from the store. As a third step, Alice will receive the packet from Bob. And we have a manager that checks the status of the packet. I will switch the screen to a local instance of Major that I have currently running. I can show you that. So we have a couple of components here. We have Major itself running, and we have a context broker together with its database. We have a key store, which is called Vault. That's quite a common tool for storing public keys, and it has a plugin to support signing transactions for Ethereum. And we also have a local node running that is an implementation of the Ethereum API, which can be used for testing purposes, in the end only to not create transactions on actual blockchains, only for demo purposes. What we now can do is do actual calls to our Major. Major currently is running on localhost 4000 for me, and as said, it implements the standard API of NGSI. Which means post to NGSI ID v1 entities will create an entity inside a context broker. The body that we send is also standard NGSI ID, which means the entity has an ID, it has a type, and I created a couple of simple properties. So this doesn't follow a certain data model, but only the model of NGSI ID. So we have a status, which will in first place be ordered. And we have a relationship to our customer Alice that it was ordered by Alice. In order to get our transaction also signed by the customer that actually is doing it, we provide 3 headers, which is the wallet type. So we say we want that this transaction gets signed from vault. We say where this vault is running and which account it should use. In this case, it's also running at localhost, and it should use the account Alice. And we also have to provide a token so that vault will actually sign the token for us, sign the transaction for us. This is in the example case a plain text token. It will, in a practical use case, be some kind of JWT that the request has to provide. If we now do the actual request to our kindness major, we will see that we get the receipt as a response. We can see the hash of the block, and we can also see the block number. In this case, it's 2, because I did basically bring up the test network before the presentation, so that we have our initial block, and now the first transaction will be stored in block 2. We have all the transaction hashes and in the end all information that we need to rebuild in the end our actual change. And we also see that this is the public address of Alice, so that we can connect the transaction in the future also back to Alice. So now, since Alice has ordered the packet, Bob can come and take it for delivery. We do an update on the same entity, which is packet 1 here again. We again have to type packet. We now change the status to in delivery. We also set another relationship to the actual courier that's doing it, which is Bob. And we tell kindness major to now sign it with a different account. In this case, it's in the same wallet, because I don't install multiple for a demo, but with another account, which in this case is the account of Bob, which we can see when we now do the post. We get back the transaction again, and we can see that the public address of the signer of the transaction is different. After Bob delivered it, Alice in the end accepts the delivery, changes the packet again. We have a new relationship to received by Alice, and we change the status to received. And we say, do now sign it again with the account of Alice. We can send the next request. We see that a new block number is generated again, and that we see that it's again signed with the public key, with the key of Alice, so that we can see the public address of Alice here. And as a last step, we say that some manager from the store wants to actually see that the packet, what the current status of the packet is. We now see a different request to the NGSI LD API, which is we want entities, and then the actual entity ID, and we say get. And in this case, since this is only viewing, we decide that we don't care which exact manager does it. We only want to know that it actually happened. So we don't set any headers to sign it, which means in the end it will be signed with the default key from kindness major. When I now do the get, we will get back another transaction receipt, which has another address, which in this case is the address of kindness major. So now all this is on the blockchain, and if we want to see in the future what actual transactions happened on our packet 1, we can ask kindness major to please give me all transaction details for the given entity, packet 1. So we do a request on kindness major and get back a list of transaction details. In this case, it will be 4 entries, 1 for the ordering, 1 for the delivery, 1 for the reception, and 1 for the get. We can count this as the first one. Here we have the second one, the third one, and also the fourth one. So all transactions are here. And we also know that the first and the third one should come from Alice. So they should have the same address, which is this one on the first transaction. And we also can see the second is different because this is signed by Bob. And the third one is again signed by Alice. So if there is now any confusion on who, let's say, delivered the packet, or if Alice actually received the packet, we can go to the blockchain. We can verify that this transaction actually happened and that the transaction was done by Alice and signed by Alice. And we can then go to the broker again, get the change on the entity, and compare it with the hash of the entity that we stored on the blockchain. So there cannot be any denial by Alice that Alice actually received the packet. Yeah, that was a quite easy example of the capabilities of Kindness Major. I will switch back to my presentation. And yeah, in the end, I can only give you a set of links on where you can basically start with Kindness Major. The first one is the official repo of Kindness Major. Then we have the running deployment for Kindness Major on Kubernetes. There is a full definition of the deployment in this link. We have a set of integration tests that makes it more obvious what the features that Kindness Major is supporting are actually available. Then we have the Docker Compose here that I currently use for the demonstration. So this can be used for running the exact same setup that I'm currently running. There is a link to the smart data model and also to the Postman collection that I used for the demonstration right now. I hope that gives you a first introduction to Kindness Major, that you might be able to use it for your projects. Thank you.
Thanks, Stefan. So we have a couple of minutes left if anybody has any questions to any of the speakers from today. It seems not. Okay. So thank you. So Stefan, there's one question for you. Is it easy to use Binance smart contract?
What is the Binance smart contract? So right now, Kindness Major is using a smart contract developed for Kindness Major. It does not support the usage of other smart contracts right now.
Yeah, if I can add to this, yeah, I mean, Binance is a blockchain network. It could be migrated, okay, if we have, let's say, something like a need for migrate. This can be migrated to almost any blockchain network which can implement smart contracts in something like compatible with the main Ethereum network. And as far as I know, Binance, for example, is compatible.
Okay, thank you.
But right now, as Stefan said, it is not working.
Okay, thanks, Jesus. Any other questions? No. Okay. Thanks everyone for the presentations today. I hope you all found it useful. We will send the presentations that you saw today by email after the event. If you have any questions or you think of anything later, please send us a message. You can also go to the Token Project website, and on there, like I said earlier, you can request a demo or send an email with any questions that you have, and we'll get back to you as soon as possible. So, okay, thank you everyone for attending today, and have a good day.
Bye.
Thank you very much. Bye.